Okay, welcome to part 2 of lesson 3 of transformations. We're going to look at a bit harder topic. We're going to look at combining reflections. So first of all, we're going to look at combining reflections in the x-axis and the y-axis and kind of look at what changes if we change up the order in which we do these. So here in this example, they first did the reflection in the x-axis, so y was replaced with negative y, equation became this. Then continuing from that equation, we reflected in the y-axis, x was replaced with negative x, and then that means that x was replaced with negative x in the equation, and we got this final equation. So reflecting the x-axis, this would have been down here, reflected to there, this point here, reflected down here, etc. And then we reflected over the y-axis. So those points went there. Okay, so as a result, you can see we ended up on graph 2. Okay, now let's try this in a different order. Complete the table below to determine the equation which results from changing the order in which reflections are carried out. So, reflection in the y-axis. Okay, so if we reflect in the y-axis, let's look at our graph. Just imagine this in your head if you don't have a graph. This point would be reflected over to here. What changes sign? Well, the x-coordinate would change sign. It would go from 1 to negative 1. So x gets replaced with negative x. Okay, in the equation, we started with y equals f of x. So in the equation, x gets replaced so that now we have y equals f at negative x. Okay, now let's actually do that to this graph. So this point is 2 away, so it would be 2 away on the other side. This point is 1, 2, 3 away from the y-axis, so 1, 2, 3 away from the y-axis on the other side. Okay, so there's our graph. All right, that's after transformation 1. Now, reflection in the x-axis. So if we reflect this in the x-axis, the coordinate that changes sign now would be the y-coordinate. So y is replaced with negative y. So in the equation, we'd have negative y equals f at negative x, or let's divide both sides by negative. Imagine there's like a 1 in front of this f of x. So that would now become negative 1. And there's our equation. Okay, now let's do it to the graph. If we reflect that over, this point is 3 away. This point up here was at 6, so now it would be at negative 6. X stays the same, and there we go, and that's after the second transformation. So compare that to the graph above. Is this graph any different than our second graph from above? And guess what? It's not. So does the order in which reflections are carried out affect the final image? No, not in this case, okay? Describe two sets of transformations in order which can be applied to the graph of y equals f of x to produce the graph of y equals negative f of negative x. So they're talking about basically these two transformations, reflection in the y, reflection in the x-axis, or switch the order, reflection in the x and reflection in the y. Okay, let's look at the next page. All right, so now what we're going to do is combine a couple transformations again. Okay, and the inverse is going to be involved. See how it's x equals and then y is on this side? Okay, so let's take a look. In each case, complete the table and sketch the combination of transformations on the grid. Okay, so first one we're going to look at is right here. First, we have reflection in the y-axis. So imagine if we reflect in the y, it's going to go this way. So that means x would change sign. So x gets replaced with negative x. Change your equation accordingly. We started with y equals f of x, generic, and replace x. Okay, reflection in y equals x. Well, that's the inverse, isn't it? Okay, so we want to switch x and y. So that means x gets replaced with y, and y gets replaced with x. There's our replacements. So from this equation here, that would now be x equals f and then negative y. The negative still stays there. Don't worry about that. X simply gets replaced with y. And there's our equation. Now I guess we should do this on the graph, shouldn't we? So reflect in the y. Okay, y is over here. So this point would be at 1. That would now be at -1. This point, 3 away from the y-axis, so 3 away on the other side of the y-axis. Same thing up here, and there we go. Okay, now next transformation was reflection in y equals x, where x and y switch. This one, I would definitely write down the coordinates here to do the switch. So moving from left to right, our points were -3 and +3. Okay, then we had the top point at -2, +6. Okay, and then -1, 3. All right, now the inverse. Okay, switch those x and y's. 3, -3, 6, -2, and 3, -1. Okay, let's plot those points. 3, -3 would put us down here. 6, -2 would put us right here. Now connect those points, because trust me, after you get these drawn, you're not sure which ones to connect. And 3, -1. And then connect that one to our last one that we drew. And there we go. Does that look like it's been reflected over the line y equals x? It does. Imagine folding your paper on this blue line here. Okay, would it land on this other graph? And I think it would. Okay, now what I would like you guys to try is the remaining 3. So we're going to do this one here, okay, this one, and this one, okay, and then we are going to check back. Now maybe what we should do is just do this next one. To make sure we're both on the right track, okay? And then we can continue with the latter two. All right, so pause your video and just do this one here, and then we'll check our answers. Okay, let's take a look. So check your replacements, make sure that you have the same as I do, as well as these equations. Okay, and then we would sketch the graph, and after the first transformation, we would end up at this one here, the blue graph, and then after the second transformation, we're over at the green graph. Okay, now if you'll notice, these are really the same two transformations, right? Reflecting in the y-axis, reflecting in the y-axis, and reflecting in the line y equals x. And same thing here, reflecting the line y equals x. But they were done in the reverse order. So, question is, did we end up with the same final graph when we switched up the order like we did on the last page? Let's compare this one and this one. Are they the same? No, they're not. So with the reflection in the line y equals x, it seems that when we combine that with reflecting in the y-axis, it does matter the order in which we do things. Okay, so please remember that. Let's take a look at reflecting in the x-axis and again reflecting in the line y equals x and see if that one makes any difference. Okay, you guys go ahead and do these two, and then we'll check and see if we have the same answer. So pause your video. Okay, welcome back. Let's check and see if we have the same answers for replacements, equations for each of these, okay, and our graphs, okay, in particular. So if you need to pause your video to check this before I continue, please do. Okay, now let's look at our final graphs. On this one, our second graph ended up over here in quadrant 2. For this one, it ended up down in quadrant 4. So these two transformations done in opposite order actually affected our final graph. So let's answer part A. Describe two sets of transformations in order, proper order, which can be applied to the graph of y equals f of x to produce a graph of x equals f at y. Well, let's look. We got that graph here, or that equation, I should say. And we also got it here, this first one. So reflection in the y, then a reflection in the line y equals x, or first reflection in the line y equals x, then reflection in the x-axis. Okay, so let's write that down. So reflection in the y-axis, then reflection in the line y equals x, or firstly, reflection in the line y equals x, and then secondly, reflecting in the x-axis. Now, let's say we didn't have all these tables to look at to figure that out. Obviously, when you look at this equation, x equals f at y, you know that we've reflected in the line y equals x because x is not where it should be, neither is y. So that's definitely has to happen. So what you can do is start with y equals f of x and go, okay, well, I recognize I need to do that, so let's do that. X equals f at y. Okay, so that's one of your transformations, reflect in the line y equals x. Then you go, okay, how do I get from this graph to this one with the negative in front of the y? Well, I'd have to replace y with negative y. So if I do that, that would mean y with negative y would reflect in the x-axis. So x would become f at negative y, and that's reflecting the x-axis. Okay, so that's one way to figure that out from scratch in case you don't have the table above. Okay, next, describe two sets of transformations in order which can be applied to x equals negative f at y. So same thing, we would look at the tables above and write down the other two and in each of those orders. Okay, I'm going to summarize that in a second, but I want to talk about how you would get this just looking at this equation. So once again, you'll notice that x and y is switched. So I usually like to start with that and go, okay, I started with y equals f of x. I now have x equals f at y. Okay, so that's a reflection in y equals x. Okay, now how did I get that negative in front of the whole thing? Well, that negative in front of the whole thing must have started off as being negative in front of x. So negative x equals f at y. Now that right there is a reflection in, if x goes negative, reflection in the y-axis. Okay, move that negative to the other side, and we end up with the answer that we're looking for here. Okay, so if you want to summarize from the table above again, okay, and I'm going to pause the video so that you can, or I'm going to pause, you're going to pause, and we'll write that down and check our answer in a second. Okay, did we get the same thing here? All right, looks good. You should be able to do this lesson assignment now, and then there's going to be a part 3, which, well, not really a part 3, but lesson 4 is also part of this homework assignment. So we're going to continue on with that. Lesson 4 hopefully will just be one part for that. Okay, good job, everybody.